Today we're beginning matrix multiplication, and it's still pretty straightforward, but it's not as straightforward as addition and subtraction. The main thing is addition and subtraction, you needed two matrices of the same dimension. For matrix multiplication, it's a little bit different. All that matters is that the columns from the first matrix match the rows from the second matrix. So if you wrote it out like this, the middle numbers here would have to be the same, and then the outer numbers actually are what become the dimension of your resultant matrix. So your resultant matrix here should be a 3 by 2, 3 rows, 2 columns matrix. So let me show you how we're going to do this. First off, let's see if we can even do the matrix multiplication. Each of these are 2 by 2 matrices. So the middle numbers match up, so yes, we can do it. And that means that our outside numbers become what our resultant should be. So our resultant should be a 2 by 2 matrix. So what's going to happen is I really now have 4 blanks here in this matrix I need to fill in. And here's what I'm going to look at. I'm going to multiply. This guy right here is in the first row, first column of the matrix. So what this means is I'm going to take numbers from the first row and multiply them by numbers in the first column. So what I mean by that is the first row is 1, 1, 3. The second row is 2 and 1. So I'm going to look at the first numbers there are 2 and 1. So I'm going to do 1 times 2. And then right here, 3 and 1. 3 and 1. So what I did was really this first row times first column. Elements in the first row times elements in this first column. Same thing here, except now I'm in the second row, or I'm sorry, still first row, second column. So I'll go first row times second column. 1 times negative 2, and 3 times negative 1. 3 times negative 1. Those are my additions. This entry here is in the second row, first column. So I'll take second row elements times first column elements, meaning it's negative 5 times 2 and 0 times 1. And then for the last one, second row, second column, negative 5 times negative 2 plus 0 times negative 1. And then all I have to do from there is just simplify this, adding them up. So I got 3 plus 3 will give me 6. Or I'm sorry, that shouldn't be 6. That should be 5. That's 2 plus 3. This here should be negative 5. This guy here should become a negative 10. And this guy down here, negative times negative, gives me a positive 10. So there is your resultant matrix from the multiplication. In this next example, it's the exact same two matrices, but now in reverse order. So it's still 2 by 2s. So we still are able to do it because those two are the same. And my resultant, again, is going to be a 2 by 2 matrix. But watch what happens. I'm not going to get the same matrix as a result. In the top left entry, again, first row and first column. So I got 2 times negative 1. Get my little stray mark out of there so we don't look like an adding there. It was 2 times 1. It was positive 1. And negative 2 times negative 5. So that's first row by first column. Let's do this guy down here. This would be second row, first column. So 1 times 1. And negative 1 times negative 5. In the second row, or I'm sorry, let's go first row, second column. So I'm going to go first row by second column. 2 times 3, and then negative 2 times 0. And then second row, second column will be 1 times 3, and negative 1 times 0. So when I simplify that, I should get 12. In the top right, I should get 6. Down here, I should also get 6. And here, I should get 3. So what you should definitely notice is that these two matrices definitely are not even close to being the same. But they came from being multiplied by the same two matrices, just in different order. So the commutative property does not exist for matrix multiplication like it does with our normal everyday multiplication. Okay, here's another example. And we have a 2 by 2 matrix. Or I'm sorry, we got 2's in the middle, so that means we can do it because these guys match. And my resultant should be a 3 by 4 matrix. So what this should look like is a real big matrix which has 3 rows with 4 columns. So let's kind of go through and see what we can find out. In this first entry, this is the first row, first column. So I should multiply first row by first column. So I'll do 2 times 1, which is 2. And 3 times negative 1, which is negative 3. Let's go down here. This is second row by first column. So I'll have second row and first column. Negative 3 times 1 is negative 3. 1 times negative 1 is negative 1. I have then, if I go down here, third row, first column. So 1 times 1 is 1. Negative 3 times negative 1 is negative 3. Or I'm sorry, is positive 3. If I go in the next column, I'd be now second row, I'm sorry, first row, second column. Make sure you correct yourself like I'm doing many times. First row, second column. So 2, 3 is the first row, 2, 0 is the second column. So 2 times 2 is 4, and 3 times 0 is 0. And this next guy, I'm going to have second row, second column. So negative 3, 1, and 2, 0. Negative 3 times 2 is negative 6. 1 times 0 is 0. I'm going to say pause the video now and see if you can complete the rest of this matrix on your own. And resume the video when you think you are ready. All right, finishing out this row, you should have had 2 plus 0 for these guys. The rest of them, negative 4 plus 9. This should have been 6 and 3. This guy should have had negative 2 and negative 9. 6 and negative 12. Negative 9 and negative 4. And 3 and 12. And then if you just simplified it from there, your answer should have looked something like this. Negative 1, negative 4, and 4 in the first column. 4, negative 6, 2 in the second column. 5, 9, negative 11 in the third column. Negative 6, negative 13, positive 15 in the last column. Okay, good job. Let's look at one more example. In this one right here, we have a 2 by 1 matrix. And in this one here, I have a 3 row by 2 column matrix. Go ahead and pause the video again, see if you can solve this problem. All right, you should have noticed right away, this was a trick question because a 1 and 3 do not match in the middle here. Just because of that, nothing else. No, I cannot. This is a no solution problem. This is something that we might say is undefined. We cannot find a solution here. However, just for simplicity's sake, we could have flipped these guys around. If I had flipped them around, then I would have matching numbers in the middle. And there, I could have solved this matrix. So let's do that one right now. Okay? Our resultant here should be a 3 by 1 matrix because our outside numbers are 3 and 1. So that means it should be 3 rows, 1 column. So it should almost look just like a little vector here. So in the first entry, this is the first row, first column, meaning first row times first column. Negative 2 times 3 is negative 6. 3 times negative 2 is also negative 6. Let's go into second row. So second row, first and only column. 1 times 3 is 3. Negative 2 and negative 2 is positive 4. Then in the last row, 3 times 0 is 0. And 2 times negative 2 is negative 4. So when I simplify this, I should get negative 12, positive 7, and negative 4 for my answer matrix.